In section 1.7, we will learn about the trig functions of any angle, and more specifically, the unit circle. So a quick refresher, the reference angle is formed by the terminal side of any angle and the x-axis. Theta prime sometimes is used to denote its reference angle. And the reference angle, which is theta prime, can be used to find the values of the 6 trigonometric functions of theta. So let's just practice finding some reference angles. Start with 207 degrees. So this is your initial side. We count by 90. So this is 90, and then 90 more. This will give you 180. So if you subtract 207 minus 180, because we've already gone 180 degrees, we need to know how much further do we need to go to get to 207, and that'll be 27 degrees. So this is going to be 27 degrees. Now remember that the reference angle is always formed with the terminal side and the x-axis. So this is our terminal side, this is the x-axis, which means our theta prime is going to be 27 degrees. Okay, let's take a look at the next example. Okay, so in our next example, we have 342 degrees. So for 342, we once again start with the initial side. We're going to count by 90, so it's going to be 90 plus 90 is 180, plus 90 is 270. And then to get to 342, if we take 342 minus 270, because we've already gone 270, then this is going to give us 72 degrees. So we're going to go 72 more to get to 342. Okay, now, however, what we want to find the reference angle. And keep in mind that the reference angle is made with the the terminal side and the x-axis. So here's our terminal side, the diagonal, and then this is the x-axis. So our reference angle is going to be theta prime. Now we know that theta prime and 72, they add up to 90 degrees. So theta prime will be 90 minus 72, which is going to be 18 degrees. That is going to be our reference angle. Okay, and then next we have negative 156. So here is our initial side. This is going to be negative 90. And then we got to think about negative 90 plus what will give us negative 156. So if you take 156 minus 90, this is going to give you negative 66 degrees. So negative 90 and negative 66, that's equal to negative 156. But the reference angle is always made with the terminal side and the x-axis. This is our theta prime. And since theta prime and 66 add up to 90, theta prime is just going to be 90 minus 66, which will be 24 degrees. Okay, let's talk about the unit circle. The unit circle is a circle such that its radius is equal to 1. Okay, so we have a radius of 1. Now, what I want to remind you that cos theta is equal to the opposite. So if this is your angle theta, it's going to be the adjacent over the hypotenuse. Adjacent is x, and the hypotenuse is your radius, r. But if the hypotenuse equals to 1, then the value of cosine is just equal to x. So associate cosine with the x value of any point on the unit circle. Similarly for y is going to be opposite over hypotenuse. So if our opposite is y and our hypotenuse is 1, then y over 1 will just give you y. So associate the sine with x over y. And tangent is opposite over adjacent. So opposite is y, adjacent is x. So our tangent is going to be y over x. The secant is going to be the reciprocal of x, which is 1 over x. The cosecant is a reciprocal of y, which is 1 over y. And cotangent is a reciprocal of y over x, which is going to be x over y. So let's take the 30, 60, 90 right triangle. Opposite of 30 is always 1. Opposite of 60 is always radical 3. Opposite of 90 is always 2. Now, here's the thing. We want the radius, which is a diagonal, we want this to be a 1. So what we're going to do is, to turn the 2 into a 1, we're going to divide that by 2. If you divide 2 by itself, you get 1. So over here, I'm going to take 2 divided by 2, which is 1. And that's what I want. I want the radius to be 1. But if I divide one side by 2, I have to divide all the sides by 2. So the x-coordinate of this point right here, if you notice, the x-coordinate is radical 3 over 2. And the y-coordinate is 1/2. Okay, the x distance is radical 3 over 2, and the y-coordinate is 1/2. So for 30 degrees, okay, we have 30 degrees here, the ordered pair is going to be radical 3 over 2, comma 1/2, where the x value is radical 3 over 2, and the y value is 1/2. Now here's what we know. We know that cosine of theta in the unit circle is going to be the x value. The sine of theta in the unit circle is going to be the y value, and the tangent of theta is going to be y over x. Okay, so in this case, the cosine of 30 degrees is going to be the x value, which is radical 3 over 2. The sine of 30 degrees is going to be the y value, which is going to be 1/2. And the tangent of 30 degrees is going to be y over x. Okay, so the y value is 1/2. The x value is radical 3 over 2. So that's going to be 1/2 over radical 3 over 2. Now you may remember that we can't divide by a fraction. So instead of dividing by a fraction, we are going to multiply by the reciprocal of the denominator. And when we do that, take a look at what happens. The denominator just cancels out because we multiplied by its reciprocal. On the numerator, the 2's cross cancel, and we're left with 1 over radical 3. Now, to have a shortcut, because we don't want to do this every time, the tangent is just going to be the y value of the numerator, and then the x value of the numerator. So numerator of the x value, take those, numerator of the y value, so y over x is going to be 1 over radical 3. And if you rationalize that, this will give you radical 3 over 3. So cosine of 30 is radical 3 over 2, the x value of the ordered pair in the unit circle. The sine of 30 degrees is the y value, which is 1/2. And then the tangent is going to be the y over x. So the y value is 1. We're just taking the numerator. The x value is radical 3, so y over x will be 1 over radical 3. Okay, so this is going to be for 30 degrees. Now what you have to do is, you have to memorize this point, radical 3 over 2, comma 1/2. So for 30 degrees, our point xy is radical 3 over 2, 1/2. Okay, let's take a look at for 45, 45, 90. So we know that for 45, 45, 90, the ratios are going to be 1, 1, and radical 2. Now, same thing, we want this radius to be a 1. So we're going to take radical 2, and we divide it by itself to make it into a 1. But if we divide one side by radical 2, we have to divide both of these sides by radical 2 as well. And if you rationalize this, this will be radical 2 over 2, and then same thing over here, radical 2 over 2. So for 45 degrees, which is going to be this angle here, okay, this is going to be the 45-degree angle. Okay, for the 45-degree angle, and I'm going to label it here actually as 45 degrees, just and I'll show you guys later why. This point, the x value is radical 2 over 2, and the y value is also radical 2 over 2. So for 45 degrees, the sine, let's start with cosine. The cosine of 45 degrees is going to be the x value of this ordered pair, which is radical 2 over 2. The sine of 45 degrees is going to be the y value, which is radical 2 over 2. And then the tangent of 45 degrees is going to be the y value, the numerator, And the x value, the numerator, that's radical 2 over radical 2, which is just going to be 1. Okay, that's for 45 degrees. Now for 30 degrees, so this will be our 30-degree angle here. We know that our point is going to be radical 3 over 2, comma 1/2. And then for 60 degrees, so this is going to be the 60-degree angle here. The ordered pair is going to be the reverse of the 30 degrees. So it's going to be 1/2, comma radical 3 over 2. So here's an easy way to memorize this. 30 and 3, they have the same number. So 30 is going to be radical 3 over 2 as the x value, and then 1/2. 45 is the same for both. So that'll be radical 2 over 2, comma radical 2 over 2. And then for 60, it's going to be the reverse of the 30, so it'll be 1/2, comma radical 3 over 2. Now you do have to memorize this. And like I said, the easiest way is to associate 30 with radical 3 because 3 and 3 are the same number. Your only options are radical 3 over 2 and 1/2, and then radical 2 over 2. So for 30, it's radical 3 over 2, 1/2. For 60, it flips. And for 45, it's going to be radical 2 over 2, comma radical 2 over 2. So make sure that you memorize the first quadrant of the unit circle since we are going to be using it quite a bit. Not just in this class, but you will also use it in calculus. Okay, so we can use reference angles to find the trig functions of any angle that's a multiple of 30, 45, or 90. So I'm going to once again make this chart. So for 30, and you should be doing this every time, 30 is going to be radical 3 over 2, comma 1/2. Then for 45, it's going to be radical 2 over 2, comma radical 2 over 2. And then for 60, it's going to be 1/2, comma radical 3 over 2. All right, so here's some examples. Find the sine, cosine, tangent for the following angles using the unit circle. So I'm going to use this unit circle here. So the first thing we have to do is we got to sketch this angle, 240. So this is going to be the inertial side, which is 0. We go by 90, so we have 90 plus 90 is 180, and 180 plus 60 is going to be 240. Then we find our reference angle. So our reference angle is going to be 60 degrees. It's with the terminal side and the x-axis. So this is going to be our theta prime, which is 60 degrees. Now here's all you have to do. For 60 degrees, what is our ordered pair? It's 1/2, comma radical 3 over 2. So this point, I'm going to label this as 1/2, comma radical 3 over 2. But you have to put in the right signs. This is where the x and y are both negative. It's in the third quadrant. So the x is negative, the y is negative. So these are both going to be negative values. So we have negative 1/2 and negative radical 3 over 2. So we take this point, 1/2 radical 3 over 2, and just figure out whether it's positive or negative. Okay, and because this is the third quadrant, this is going to be negative 1/2 and negative radical 3 over 2. Okay, so now let's find the sine, cosine, tangent. So sine of 240 is the y value, which is going to be negative radical 3 over 2. The cosine of 240 is going to be the x value, which is negative 1/2. Let me write this a little bit better. So we have sine of 240 is the y value, which is negative radical 3 over 2. Cosine of 240 is the x value, which is negative 1/2. And then the tangent of 240 is going to be y over x. So the y value is negative radical 3. The x value is negative 1. So if we do y over x, that'll be negative radical 3 over negative 1, which is just going to be positive radical 3. Okay, we got our sine, cosine, and tangent. So these two here, letters B and C, we will do these in class.